Okay, so you rejoin me. This is statistics 1.3. I'm doing some of the problems. So these are kind of problems we would do in breakout groups or all together kind of thing. But today, since we are doing this kind of on our own, I'm going to have you do these two things. The one on the left that you see here on my screen, this is the one, the first one that comes up, it says a small group. So I'm going to have a start with that. This is kind of a recap of things that we've done so far. There's a histogram there. There's some data. They're asking us to do a few different things. And then on the right-hand side, that's the second one. That's the one that just says Boxplot problem. So that's a Boxplot, and we'll kind of start working on that one there in just a moment. Okay. So let's get started with the first one. So if you need to, you can go to your Google Drive and go ahead and grab this worksheet. And I'll walk through it with you. This has got just a good kind of AP style problem, just get us to do this. And then on the other one, it will be the box plot problem. So you can get that one out as well if you wanted to. That would work as well. So with this first one, what we're going to do is put this data in. Right now, I would put this either into my calculator, TI-84, or if you want to, you can go to your Staplet. .com. Let's get the right one going here. So I'm going to go here. So this is, remember, this is quantitative data right here. It says some students purchased pumpkins for a carving contest. Before the contest began, the weight of pumpkins, weights in pounds, are shown here along with a histogram of the data. So there's a histogram there. I can already kind of start assessing parts of this, but let me just talk about that histogram I'm looking at. It looks like it's skew right already. Now we should be able to find that same thing here. I'm going to try to get this computer program to actually match what we're seeing there. So let's see if we can do that. Quantitative variables, it's one group of pumpkins, right? The weights for the pumpkins, one group. So I'm going to go single group. Variable name, let's see if we can do, the variable name is pumpkin. Pump, I'm going to call it pump weight. I'm going to go pump weight. I know. Yep, we got it there. Okay, we're going to input raw data. Now, so it just says you can do commas or spaces in between. I'm going to do commas, 3.6, comma, 4.0, 4.0, comma, 9.6. I'm just going to keep on going down the line here. So just give me a minute as I get this done. Looks like 11, 12.4. 13, 2, 6, 6.6, 15, 3.4. All right, there's half the data. I'm going to keep trucking along here. Now, if you got all this entered in already, you can probably fast forward just a little bit. Avoid watching me type super slow here. Hope I'm not messing up any of the data, right? Some of the worst parts of statistics is data entry error. Right, we get that all the time in the real world and business. So hoping for a good data set here. All right, I think I got them all in there. Hope they're all good. So let's do begin analysis. Remember, it comes up right away with the dot plot. Dot plots are great to look at just because it gives us a real quick sense of shape for sure, right? Shape's there. I can see anything that looks like it might be outliers. That's kind of the first thing. But again, I want to take a histogram and let's see if we can make it match what we see on our data set. This is pretty good because my histogram already split it up 0 to 5, 5 to 10, 10 to 15, 15 to 20, and so on. That's awesome. This looks like what that worksheet. Go ahead and take a look at worksheet. Take a look at this. They look great. So this, I'm guessing I got my data put in pretty well, right? So let's look at number one. It says, calculate the mean weight of the pumpkins. Remember down here, this already doing it for us. It added all those pumpkins together and it divided by the number of pumpkins that we had there, which looks like 23 total pumpkins. And it got us 9.935. So let's just enter that in. Mean weight of the pumpkins, 9.935. Is that right? Let me just, sorry about that. Quick double check. Stay with the histogram there. 9.935. Actually, let's do this in a slightly different color. Let's go 9.935. Doesn't tell me necessarily what they weigh the pumpkins. I guess pounds. I'll weight in pounds. There it is. There it is, pounds. Okay, 9.935 pounds. Now here's the deal. One of the things that you'll start seeing is this has a symbol to it. We used an X with a bar above it. So that is the symbol for mean. The mean weight of pumpkins is 9.935 pounds. Okay, so that's what that looks like. Let's shoot over here and still with this same data set. On here, you can see it gives us the N, that's the number in there, the mean, the standard deviation, the minimum, the Q1, the median, the Q3, and the maximum. The median, 6.6, that is the value, right? And now if I list those from least to greatest, it's gonna be the one that's directly in the middle. So 6.6, median, we like to use a capital N, 6.6 pounds, okay. And so that would do it right there. Let's just increase this size real quick. All right, I just want to real quick talk about what we believe the SOX might be in this thing, right? So SOX is shape. What is the shape of this? Well, if I were to just draw right over the top, here's the group right here. That's the main group. And then I got to stretch to the right to capture the rest of it, right? So we would call this skewed right. Outliers, are there any outliers? Well, outliers are things that are separated from the group. So out here, it looks like there are 2 values. So obviously if I go into my data set, it looks like 31 and 33. I'm gonna classify those as potential outliers. Now, if somewhere in the question they need me to verify that they're outliers or not, I'm gonna do the 1.5 times IQR rule, which is what we just saw in the video previously. But for this one, I'm just identifying it. Center, we just talked about the mean and the median as centers. And then the spreads, if I'm using the mean, right, the mean, I should be using the standard deviation as well. So the mean and standard deviation go together. If I'm using the median, then I would like to use the IQR as the measure of spread, median IQR. So those are, if I was talking centers. Now they asked me both centers, so I went ahead and gave both centers. And then I would give the spread. So that's some things we're going to talk about as we move into this. But the question says, would you use the mean or the median to summarize a typical weight of the pumpkin in the contest? Explain. So notice these numbers are off, right? They're both measures of center, but one is 6.6 and one is 9.93. So let me think about, all right, mean 6.6 would put it right around here, right? That's about where my median is. I'm going to use green here to talk about 9.9. 9.9 is going to be over here somewhere, right? A little bit to the edge. I really kind of put the median probably too far over on that. But the idea is the mean has been moved closer to the right. And wherever your skewness goes, right? Wherever the skew goes, skew is going to the right, the mean will follow along the skew. It will be pulled that way because the mean is not resistant to extreme values. So if 31 and 33 are considered extreme values, the mean is going to be influenced and pulled that direction, where the median is a resistant value. So it's not necessarily going to get pulled to that. So the median here is actually the better measure of center because of the skewness and possible extreme values. Since median is resistant, we want to use that more often. So to answer the question, the mean or the median, I would use the median to summarize. Because there's possible extreme values and a skew to the right, we don't want it to be influenced. The median would be the better answer to that. Right now, if it's more symmetric in shape, like if those 31 and 33 were not there, I would go ahead and use the mean. Mean's a great measure of center, and we love to use the mean as often as we can, unless there's extreme values involved or unless there's severe skewness involved. So on this, looks like some extreme values and some big skewness. Let's not use the mean on this. All right, so there you go on that one. Now let's go ahead and open up that other one, describing quantitative variables. All right, following box plot shows the total income of 40 randomly chosen households, each from Connecticut, Maine, Massachusetts, based on U.S. Census data from the American County Community Survey. Compare the distributions, annual income of the 3 states. So here's a key word here is compare. Compare means socks, but how do they relate towards each other? So thinking about socks here, okay? So let's start here. I'm just gonna divide this up like shape. What is the shape? So Maine, Massachusetts, both have, this is called a modified box plot. It's when we show the outliers. So like I'm gonna look at Massachusetts. The outlier is shown with a dot, and then the next value that's not an outlier, the highest value, non-outlier value is where the whisker goes to, right? So we know there's one outlier on the upper end of that. In Maine, there's one outlier on the upper end of that. And in Connecticut, no outliers because they used modified box plots for these, okay? But we would say that, let's go ahead and say Maine and Massachusetts are both skew right. And how can I tell that they're skew right? It's because those outliers, they both have whiskers trailing off to the right a little bit further than the ones on the left. And the outlier is even extended. It extends that distance even out further. So it is skew right, where Connecticut is symmetrical. Now it's not perfectly symmetrical. I can see that there's maybe a little bit more to the right, but for the most part, I'm gonna call it symmetrical, right? Because in statistics, we wanna go skew right, skew left, or symmetrical. It's looking a lot more symmetrical in nature. Outlier. Well, since again, modified box plots, we're gonna say that Maine and Massachusetts both have upper outliers, where Connecticut doesn't have any outliers. And again, comparing is you need to make sure that you're putting however many sets they have. They have 3 data sets here. We want to talk about how the socks are related amongst all 3 data sets. Okay, let's talk about center. So center, we get to choose mean or median. Now, since we're looking at box plots, let's talk about the medians, because we can see clearly the medians. It's the middle of each of these boxes, right? I'm going to highlight in green here with each of those, right? So it looks like I'm going to go ahead and say Massachusetts has the greatest median value, with Connecticut right behind, and Maine has the smallest median value. All right, just something like that. Quick comparison. And I know my handwriting is sloppy because I'm trying to write fast so I don't take too long of a video. But this is the basic idea, right? I want to just say which one goes with which. And then finally, spread. Now, since we are talking about median, we usually want to talk about IQR, and it lends itself nicely when you're talking about a box plot. So box plot, what do we have? And it's really by vision. Man, Maine and Connecticut look real close on the IQR. Massachusetts has the biggest. So we're going to say Massachusetts has the largest IQR, where I'm going to say Maine and Connecticut are about the same. About the same IQR. That's probably not good English there, but you know, you get the point, right? So that's what it looks like right there. So compare the distributions, compare socks amongst all 3 right there. So I just really, I mean, AP, are they going to mark you down for going SOCS? No. Feel free to do that if you like it. I'm not kind of a bullet point person, so bam, 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 bullet points on there. So there's working through those worksheets together. Hopefully you were able to kind of identify that and do that. See what you can do on your own. I'm gonna have some Khan Academies to kind of finish out here the day. Make sure you get those done. Any questions that you may have, just kind of shoot them my way. You can even throw an email